What do we got here? Homework 8-2 backside. Time it takes in seconds for a sound to travel 1 kilometer is modeled by t equals 1,000 over 0.6 t plus 331, where t is the air temperature. Now, up here, this is 1,000 meters. All right. How long does it take for the sound to travel 5 kilometers? Well, if you want to know about 5 kilometers, you change the top to 5,000 understood meters. So little t for time is that. It says big T is the air temperature in Celsius. So all I've got to do is plug in a 25. So time is 5,000 over 0.6 times 25 plus 331. And that's just a button pushing, isn't it? Let's see here. Math, number, numerator over denominator. Well, you know what? I don't feel like doing that. 5,000 divided by master set of parentheses, 0.6 times 25 plus 331. There you go. Takes about 14.45 seconds. B says, suppose you are 1 kilometer from a lightning strike and it takes 3 seconds to hear thunder. Using technology, graph the function and use the graph to estimate the air temperature. So this would be 3 equal to, because it takes 3 seconds, 1,000 over 0.6 t plus 331. It's not that hard to do. You know, I don't even know why it says use tech. This is easy. I'm just going to do it by hand. So 3 times 0.6 t plus 331 is 1,000. 3 times 0.6 would be 1.8, because I'm going to distribute in. 3 times 331 would be 993. Equals 1,000. 1,000 minus 993 would be 7. And I'm going to divide by 1.8, which is, what, 18 tenths. And 18 tenths, by the way, reduces down to what, 9/5? So I'm just going to divide out that 9/5. And then I multiply by the reciprocal, which is 5/9, and I get 35/9. 35/9. Oops, this is degrees. This is degrees Celsius, which probably isn't what you want to know. Like, what is 35/9? It's a little over 4 degrees. Yeah, I believe so. A little under 4 degrees, sorry. That would be 3.88 degrees. I cannot write. Let's say 3.89 degrees, because it will round Celsius. Let's see if I'm right. You did say use technology, didn't it? 1,000 divided by parentheses 0.6x plus 331. Boom, 6. Really hard to see, but there's a blue line there. Second trace 5. Enter, enter, enter. Yep, 3.89. What's up next? Number 8. The energy an item possesses due to its motion is called kinetic energy. You learned that in middle school. Kinetic energy of an object, which is measured in joules, you probably didn't learn that, varies jointly with the mass of the object and the square of its velocity. I skipped this section with y'all. Varies jointly. Joint variation is any equation in the form y equals kxz. This says y varies jointly with x and z. There's k for constant, which probably replaced with the letter a, but it stands for constant. So we vary jointly with the mass and the square of its velocity. So this kinetic energy, which we'll call E, varies jointly with some constant times its mass times its velocity squared. Now, if the kinetic energy of a 3 kilogram ball traveling 12 meters per second is 216 joules, so they gave us the energy. We don't know the constant. We know the mass is 3, and it's traveling at 12 meters per second. That gives us enough information to figure out the constant. So 12 squared is what, 144 times a 3 would be 432, I think. Yeah, it is. 216 equals 432K. Divide by 432, and the constant is a half. Awesome. Now I know what that is. So I have the actual equation for energy here. Energy is 1/2 mass velocity squared, which is the right equation here. It is. Don't believe me, take a physics course. Not a conceptual physics course, an actual applied physical course. Physics. What is the mass of a ball that generates 250 joules when traveling at 10 meters per second? So now I worry about this. The energy is 250. It'd be half its mass, which is unknown, times a 10 meter per second squared. So that'll be 100. So I'm thinking 250 over 100 is 1/2 its mass. 250 over 100, what? If you like decimals, because some of you like decimals, 2.5. Sometimes I use them too. I give them a lot of crap, but sometimes I use them. But if you counteract the halving by doubling, your mass is 5 kilograms. See, the last one I have bolded here is number 10. I did 10 so that maybe you can do 11, because kids just can't SOHCAHTOA. This talks about the sine of angle A. SOHCAHTOA only applies to right triangles, so I'm going to draw a right triangle. And I'm going to think about what the sine ratio is. The sine of an angle is opposite over hypotenuse. So opposite of this side A, or this angle A, is a √3, has a hypotenuse of 2. And then I'm going to do a little bit of Pythagorean theorem, because I don't know this side. I'm going to do x squared plus √3 squared equals 2 squared. And I'm going to get 1, because this is a 30, 60, 90 pattern. X squared is 1, because this is a 3, that's a 4, x is 1. This, by the way, is a 30, 60, 90 pattern. 30, 60, 90 pattern was x, 2x, x √3. This happens to be a 60-degree angle. But anyways, you probably don't know that because you guys think you were good at geometry. No, you weren't. No offense. But this ended up being a 1. Now, the tangent ratio of angle A would be opposite over adjacent. So that would be √3 over 1. All right, so that's been done. I got to find that. I'm going to assume you don't know 30, 60, 90 theorem. So if the sine of angle A is √3 over 2, then the measure of angle A is the arc sine of √3 over 2. And it's going to be 60 degrees. All right. So I'm going to make sure my calculator's in degree mode. And I'm just going to type arc sine √3 over 2, and it's 60 degrees. All right, so I did both parts. So now you can do 11. There you go, boys and girls.